The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
For decades, scientists tried to warn us about the atomic super tornadoes filled with jellyfish, but we didn't listen. By then, it was too late. The tornadoes melted the polar ice caps, turning our planet into a water world. Things got worse when a comet hit and dried up all the oceans. It's the apocalypse now, and I'm mad. An irradiated worm. First food I've seen in 7 moons. Looks like it's my lucky day.
What we having this here one now then?
Another wanderer like me. Do I waste them and reclaim my precious worm? Or try to work out some kind of deal to preserve as much of my humanity as I have left? Bottle caps. I've got some.
Is that so, Governor? How many then?
Enough.
Well, maybe I'll be taking them, as well to see a dinner here.
Something new, my friend. Since the dawn of time, wars have been fought over the scarcity of resources. And now, your pathetic, puny human race is reduced to fighting over a worm. By the way, I'm a super mutant.
You know something? He's right. We shouldn't be fighting over this worm.
Yeah, especially when there's plenty of other awful in this wasteland to fight.
Right, like killer sloths.
I hate those.
Here you go, friend.
Thank you. And here's some caps. There's nothing to buy in this world anyway.
This warms the cockles of my heart, because friendship never changes.
This game is fun and all, but all the talk about eating worms is making me hungry. I kind of wish there was a way I could eat food and continue to play video games at the same time. It's the American dream. Wait a minute, I know. I could recreate the Hot Pocket video game controller project, but for the next generation. Let's get started.
Amazing hacks.
How can we make this portable?
Inspired designs.
I am the internet troll.
Regrettable acting.
Batten down the hatches!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Fallout 4 is finally out, and I've been playing it a lot. And I figured this would be a good time to revisit a classic project of ours, the video game controller Hot Pocket Extruder. The original project was a Hot Pocket dispenser that fit on top of an Xbox 360 controller. But there are a lot of things I wanted to improve upon with that project, and I figured now is the perfect time to do it. So let's look at it. So next gen Hot Pocket dispenser, so it attaches to the PS4 controller on top through the USB port. It will have a wall wart on a really long cable, so it'll charge your controller so your controller will never die. And it will also extrude the Hot Pocket for you. Here are the parts. 5-volt regulator to take the 12-volt wall wart down to 5 volts and charge the controller, and also used for the logic of the H-bridge, which will actually drive the motor forward and back. And there'll be a small DC motor, which will be hooked up to a shaft with a captive nut, driving the actuator back and forth to extrude or retract the Hot Pocket. So the main steps are to design something that will fit the top curve of the controller. That can be a little tricky, but we'll figure it out. And then once we have everything working, basically rudimentary test parts, we'll redesign it to have a retro futuristic look that will fit the Fallout aesthetic. Let's get started. This is the PlayStation 4 controller that many of you are no doubt familiar with. There's a charge jack here. So I bought this right angle micro USB, and that can plug in right there. I shaved a little bit off the top so that it is flush with the top of the unit. So what I want to do is I want to have something around here enclosing the unit and connecting to this plug, and this plug will actually hold everything in place. So I'm going to start doing some simple, small 3D prints to figure out the angle of this. It looks like it's about 30 degrees. Of course, when the controller is held like this angle's down, so the Hot Pocket will probably be right about here. All right, now to get some angle tests. Hey, I'm liking this one. It fits the back of it well, and also the curve is nice and tight. So I think this is the right direction to go in. So I don't need that anymore. I've created an extruded version of that same angle, and I want to have a gap here for the plug. There's a curve here, which I kind of want to avoid, so I'm going to keep printing these and get it dialed in as close as I can. Nope. This could be a winner. It fits the back of the controller well. It doesn't impede this stupid touchpad they added for no reason. The touchpad still moves. You can still hit the share and option buttons. One challenge we have here is I want these tines to come over to give us, basically to help hold on to it. However, they get in the way of these buttons. So there's two things I could do. I could make it bigger and then reproduce the button. So the button's part of the 3D print. So you'd push the 3D print and that would push the button. Or I could make the 3D print come between the button and the touchpad and come down here. But the problem with that is when you're printing it, you'd have a skinny piece and an overhang, so I'm not sure if that piece would print properly. Yeah, I like the idea of using black, making it fit the controller. Although I think I'm gonna paint it with a retro 50s steampunk aesthetic. I think I've got a pretty good angle here for the attachment plate. So I'm gonna build this project in pieces. There'll be an attachment plate, a main Hot Pocket extrusion chamber, and then a rear portion that'll have the extruder motor on it. So I think what I need to do next is test actually how to push a Hot Pocket. I'm going to do an example now where I try to move a Hot Pocket using a motor. I've heat shrunk a screw onto the shaft of the motor to give us a little bit of linear motion. Then I 3D printed this as a test pusher. And this isn't gonna go very far, but it's far enough. We just need to see if the motor has enough power without gearing to extrude the Hot Pocket. So we're gonna try a varying amount of degrees. We're gonna try 0 for starters. Wow, it was over before I knew it. Right now I've got a manual H-bridge. Oh, looks like it went too far and bound up. So we'll have to have physical limits that occur before the screw can bind itself up. But that's a design issue, so. All right, let's try an increased angle. 45 degrees. So there's no track guiding this pusher, which seems kind of haphazard. However, the way to look at it is, if it works in this condition, it'll certainly work in better conditions. Does that make sense? It's like we're launching a rocket. It's like, load up to the top stage. The Hot Pocket is moving to the launch platform. The whole world has waited to see if this will work. All right, we're gonna try it at nearly 90 degrees. Did not work that time. Oh, there it goes. Okay, cool. Well, if we can get it to move with this crappy setup, it'll definitely move once we design something better. So that'll be our next step. Okay, we've tested the motor extruding the Hot Pocket and we know that it can do it. So I'm drawing an idea here in 2 dimensions into, of course, Adobe Illustrator because I love it. Okay, so we have the end view here, which has a pusher element, which you've already seen, although we may need to redesign it. And this is going to have 4 tines along it. And these tines will go into slots, allowing it to stay nice and straight. At the base of it, there will be a captive nut, and we'll use a size 4 nut. And that will be driven by our stepper motor. So here's your motor. We're going to 3D print a coupling to attach the motor shaft to the 440 threaded rod. Here is a representation of the nut that will propel the pusher plate. Here's the pusher plate. It's got these 0.6-inch tines here. On the end, there is a nylon washer, which will just receive the threaded rod, but it will just rotate within the washer. So that's our basic design. This green thing here represents the size of the mounting plate. And I did a test. We have about half of the Hot Pocket hanging out at the beginning. Even at an angle, the Hot Pocket has enough structure, it doesn't tip over, so that's good. And I also drew a beginning and end of it. So this is it at the beginning, and this is it when fully extruded. So it moves about 2¼ inches. Yes, that's correct. Now that we have the 2-dimensional design figured out, we can create the 3D parts to print them. It's time for a tech timeout.
Hi, I'm Karen, the new social media ninja for the Ben Heck Show, and we're looking for your build ideas. Every month, Ben, Felix, and I will discuss the top 5 build ideas submitted to the Element 14 community. If your idea makes the top 5, you'll win a Ben Heck Show t-shirt and the chance to have your build featured on the show. So go to element14.com/TBHS and click on Help Ben Solve Problems to submit your ideas. Look for upcoming videos in the bonus content section of the Ben Heck page. We'll see you there.
Here is the 3D printed piece that we just created. And here's our pusher from the earlier step. I made it a little taller just to make sure it could hold all types of Hot Pockets. So see how the tines go into those grooves? Yeah, that will prevent it from having too much tilt because the lead screw is gonna be on the bottom, so we don't want it to tilt too much. So that's gonna be back here in a part that we have to build yet. So it's basically a linear actuator with a drive screw. And then we'll have our nylon washer here, and that will be where the screw terminates. So once we actually know how this will all put together exactly, I mean, I have an idea of how long this lead screw should be, but I'm gonna get the real measurement from what we actually build before I cut it down. So let's make sure it fits the Hot Pocket. Look, you can eat Hot Pockets without using your hands, allowing you to play as much Fallout as possible, because you should, because it's Fallout. That looks pretty good. It's got plenty of clearance, so now I'm going to print the end piece that actually holds the motor. I printed this one in white just because I had to use both printers, and I don't care what color it is because I'm gonna reprint it anyway. And there's a gap in the back for crumbs to come out of. Oh yeah. So let's put this together. You've got our rumble motor here. I'm gonna put it through the slot. There's a little gap for the wires to come out the side. And since these rumble motors are all coated with foam, I actually took the foam into account with my measurements, and that is what gives us a nice snug fit. Ah, look at that. So this is going to plug in like this, and then we will put a captive nut in this hexagonal depression here to hold the pusher. And then I also printed some small little caps to hold the nut in place. So I'm gonna get this glued together on my bench and then we can try it again. I'm now going to start building some electronics into the base unit. I'm gonna plug in this USB port here. I shaved off the top to give us some more room. And this is our base. And it's probably gonna have some leather attached to it. But for now, I'm just gonna start with this. So see how it goes around the plug like that? So that's pretty good. So guess what I'm gonna use? That's right, hot glue. It's simply the best. Better than all the rest. So the parts that are gonna go in this are a 5-volt switching regulator. This will give us a very efficient 5 volts to charge the controller. And then this is a motor driver. It's already built into a package, so we can pretty much just stick this in, add a little bit of a heat sink, and we should be good to go, instead of having to wire up an H-bridge manually, which would take up a lot more room than this. So these are gonna fit in there kind of like that. And then once we have the base done, we're basically gonna redesign this to give it a retro futuristic styling. That's perfect for the Apocalypse. So I laser cut this piece of leather. Oh, and it definitely smells wonderful, but you know, the smell of burning flesh is something you have to get used to in the Apocalypse. The idea with this is it'll attach to the top of the frame and then loop around to the back and probably connect with some Velcro or something. This will remove strain of the weight from just the plug itself. It will pull the strain forward and then go around the back. So I'll probably trim down these tabs, and then I actually made some marks so that, because this goes over the option and share buttons, so stupid. But it's labeled so you can just push the leather to push those stupid buttons. And then you still have access to this pointless pad. You can't just hook up 5 volts and ground to the PlayStation 4 controller and expect it to charge. It needs a signal of some kind, either a computer, PlayStation 4, or you can tie the data plus and minus lines together in order to command it to charge itself. Next, we attach a motor controller to a small PCB, along with a 5 volt switching power regulator to drive the motor controller logic and charge the controller. We then Dremel out a large spot to fit the charge jack. All right, let's see if the controller charge part of this works. I put a plug in here so we can remove it, so we can, wire up the rest of it when the time comes. So this plugs in here, and your really long cable that we made goes to your wall outlet. Okay, yep, it's glowing. You can't see it through the slit, but it's definitely glowing. All right, so it's charging, which means that part of it is good. So now I'm going to add the motor controller. Felix already did a test to make sure that the one we had laying around will work. So I'm just gonna copy the schematic and build it onto this little board. Okay, I have the circuitry done. This is where the 12 volt comes in. This is the 5 volt switching regulator. This plug is what actually charges your controller. This is the motor controller here. It's more than big enough for what we're doing. This is the plug that goes to the motor, and then there are 2 resistors that are pulling down, and we'll connect that to our switches. So this part is pretty much done. I just have to finish designing the case, and then we can do the final wiring. I have the final pieces 3D printed for our futuristic Hot Pocket extruder. So we have the base here, which has the buttons for forward and back extrusion, the USB plug to connect it to the PS4 controller, this leather piece, which will help hold it in place. This is the power jack, so it'll charge your controller and run the motor. This is my cool motor mount here that I made. It's got a spring and some foam to prevent it from binding up when it is fully retracted. There's an end cap on it, the wire comes out here. And then it goes into this snazzy, space age looking shell that I made. So I'm going to assemble this, and then we'll paint it and eat some Hot Pockets. So Karen, you just carry all these paints with you wherever you go?
Oh, sometimes.
I see. So we need to think of a color scheme for this. What do you think?
Well, I think we need to definitely have some metallic in there.
Right.
So we've got these fancy pinstripes here. Maybe a nice silver
For the pinstripes?
for the pinstripes.
I keep coming back to blue, like a 57 Chevy, because
Okay.
apparently they're all blue. I mean, it's hard to tell, those movies back then were black and white.
Yeah.
But I think they were blue, and I've seen them in parades.
Well, conveniently, I have a bottle of blue right here.
Sweet, and if it's too dark, we could mix it with white.
That is true.
We can do anything with paint. It's almost like Photoshop. So I'm gonna click on this. There, done. Kind of sucks that Bob Ross died, huh?
Yeah.
Hey, wait, Karen, you know who LeVar Burton is, right?
Yes, and I heard that Reading Rainbow's coming back.
Yeah, they did a Kickstarter.
Yeah. He seems pretty excited about it. I don't know if that's like fake excited or real excited.
Now that the paint is dry, I can glue the 2 pieces together. I've left a blank space with no paint for the glue to adhere. Oh yeah. Okay, the yellow light is glowing. Hey, and it also fulfills the purpose of blocking the stupid light in front of your PlayStation. You know, if you remove the LED from your PlayStation controller, you can actually improve your battery life. They improved it with a controller update. Oh, what have we come to in this world? But it still consumes way more power than it should. Time to play some video games. The scene's too action-packed. Wow, how convenient this food is. Searing hot filling, burning my lips. Pew, pew, pew. Oh, that's meme-worthy. I'm sure everyone on Twitch is gonna care about this scene that just happened. Share! For this project, our challenge was to create a next-gen Hot Pocket Dispenser for the PlayStation 4 controller. The idea is you can eat food and not have to take a break from gaming. Improvements we made over the original version include built-in controller charging and a motorized linear actuator to extrude the Hot Pocket as you consume it. I feel we met the challenge of improving upon our original design, and I'm quite happy with the atomic retro look we created for the device. Things we could have done differently: I thought about adding a heating element to keep the Hot Pocket warm, but we didn't really have the space, and that's not super useful anyway. Have you ever built a food-based gadget? How do you balance dinner with gaming? Let us know in the Element 14 community, where you can also keep track of our upcoming episodes, builds, and special events. We'll see you next time. I'm an American. Like $100 pledge level, you get a real broken beer bottle from the set.
All right, so the answer to your question is I am not good at a Cockney accent.
The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.